Researchers developed clean energy from graphene for the first time.
A team of physicists from the University of Arkansas has developed a circuit capable of trapping the thermal motion of graphene and converting it into electrical current. They learned to extract energy from the thermal motion of carbon atoms. The scientists' experiment showed that under the influence of eternal chaotic thermal motion inside graphene, a single fixed plate of this substance, one carbon atom thick, slowly vibrates and bends.
Strange that they describe it as the external chaotic thermal motion inside of graphene.
A graphene-based energy-saving circuit can be built into a chip to provide clean, limitless, low-voltage power for small devices or sensors, said Paul Thibodeau, a physics professor who participated in the experiment. To convert the vibrations of graphene and the resulting alternating current into direct current, physicists from Arkansas proposed a circuit with two diodes. This experiment proved that the circuit generates additional power at the load. According to the researchers, based on their methodology, one can create a million different schemes.
So here's an animation, and apparently, so there's an electrode that's really close to the layer of graphene, and I guess it's an atom thick. I mean, the layer of graphene is an atom thick. I don't know how close the spacing is between the electrode and the graphene, but I guess because it's vibrating constantly, for some reason, well, because this is happening really fast, right? So they use these diodes as kind of like a one-way trap, and something happens where there's like a lower resistance when it goes through the diode, and because of that it amplifies the charge, and somehow there's an excess amount of power being generated on a very, very small level, and they can charge it up, and they can store it in the capacitor and then use it to power something really small, which is really strange. Apparently this is you're not supposed to be able to do this according to Brownian motion.
Earlier, the idea of harvesting energy from graphene was controversial because it refutes the famous assertion of physicist Richard Feynman that the thermal motion of atoms, known as Brownian motion, cannot produce energy. However, the team found that at room temperature, the thermal motion of graphene actually causes an alternating current in the circuit.
Yeah, so it's strange. It's strange that this this team, I don't see. Yeah, it just says researchers. I don't see where it specifies on this free news article. But it's very interesting that they've just all of a sudden they've made this discovery.
We redirected the current in the circuit and turned it into something useful. The next goal of the team is to determine if a constant current can be stored in a capacitor for later use. This goal requires miniaturizing the circuit and applying it to a silicon wafer or die. If millions of these tiny circuits could be built on a 1 by 1 millimeter microcircuit, they could replace a low-power battery, the scientists noted.
Okay, so apparently the circuit is just kind of theorized. They know that the graphene produces an alternating current, but yeah, the next goal of the team is to determine if the constant current can be stored in the capacitor for later use. So apparently they haven't made a working model of this. I mean, maybe this is just an idea. Let's see. We go back and look at Science Daily article. I don't know if it specifies the science team at the University of Arkansas. The Science Daily article seems like it goes into depth a little bit more. So, very interesting. I would imagine that they would be using this for sensors in space, possibly. Or, I mean, it doesn't really matter whether or not they're used here or in space, but it's definitely very interesting that they've all of a sudden discovered this.